In this lesson, we're going to take a look at endothermic and exothermic phase changes, and we're going to do that with both a temperature versus time graph that shows some phase changes, and also by thinking about particle arrangement. Now, think about these terms, endo and exo, and then thermic. So thermic refers to thermal energy. Endo means into, and so in an endothermic reaction, thermal energy comes into a substance. It has to come from somewhere. It comes from its surroundings. In an exothermic phase change, the exact opposite things happens. Thermal energy leaves a substance and exits to its surroundings. So it's easiest for me to think about this in terms of what this causes the particles to do. Now, phase change means we change from solid to liquid or liquid to gas or from one phase to another phase. And so if we think about a gas, I have to put these particles in a container because gas particles bounce all over the place. And that's because they have enough energy to overcome the forces of attraction that will hold them together. So they're moving around, they're moving fast, they bounce off of their walls, they bounce off of the containers, they have lots of energy. This makes them unstable. They would, if that energy were to leave, or if they could come in, if that energy were to leave, they would fall together into a liquid, and then they could fall together into a solid. So then if I have my liquid takes the shape of its container, all those particles have to stay together, but they do take the shape of their container. And so in this liquid, that's a little bit stable and a little bit unstable. And then we have our solid, and in our solid, those particles are all in their fixed positions and they don't shift from there. Now, they are able to vibrate back and forth in place, but they don't actually shift out of position. So this is the most stable we can get. This is our solid. And then it's a little less stable and a little less stable still. And that's because these forces of attraction have stabilized these. They've lost enough energy that those forces of attraction are able to hold them together. Now, we can move from any of these states to any other of these states. So if I take a solid and I change it to a liquid, we call that melting. And melting is endothermic because we have to put energy into that solid to get it to change into that liquid. It's an endothermic reaction. It's not a reaction, it's an endothermic change. Energy goes into that solid, and then those particles can leak all over the place because they're a little less stable now. They're able to shift position. The opposite of that is freezing. And freezing releases energy. Now, if you think about that, if I want to take a liquid and change it into a solid, I have to pull energy out of it. So energy has to leave that system, and it has to go somewhere. It's going to go to its surroundings. And in fact, something that orange growers do is if they're expecting a light frost that would damage their crop, they can just go ahead and spray all of their trees with some water. And then as that water freezes for the light frost, it releases its energy as it changes from liquid to solid. That energy will go into the orange, prevent anything from freezing there, and save their crop. Now, if it's a heavy freeze, then of course it would still release that energy to the atmosphere and its stuff would still freeze. So it only works on a light frost, but we can actually use that energy that's released from a liquid changing to a solid to prevent other things from freezing. And then we can go from a liquid to a gas. This is called vaporizing. Of course, if I want to take a liquid and make it a gas, I have to add energy to it. This is an endothermic change as well because we're putting energy into the liquid to make it change to a gas. And of course, we can undo that. We can allow condensation to occur. And this is exothermic because we have to let the energy out of these particles so that they can condense into a liquid. And in fact, you're probably familiar with this exothermic change if you've ever put your hand above boiling hot water. Because you know what happens is there's steam coming off of that, and when it hits your hand, it gets really, really hot. And then you get liquid water droplets on there. And that's because that vaporized gas is releasing energy into you as it changes back into a liquid. Now, we can also go from the solid to the gas state. And we don't think about this one because we don't tend to see it as often, but we can go from a solid to a gas. That is, of course, an endothermic change, and this is called sublimation. Okay? And it's endothermic as well. And so we put energy into a solid and it goes directly to the gas state. This actually happens in your freezer all the time. Ice cubes get smaller because they sublimate into a gas. And then we can have the other thing happen. This is called deposition. And that is, if you think about it, the word deposit, that's when a gas deposits onto a surface. Frost forms from deposition. And of course, this is exothermic. We have to let those particles release their energy in order to get them more stable so that they can come together as a solid. Now, I also said we would look at a graph for this. So if I look at a time graph, so time goes this way, and temperature here, we're going to have warmer and we're going to have cooler. If I have a graph that, say, starts like this, and then flattens out and goes up like this, and then flattens out and then goes up like this. During a phase change, the particles are rearranging. They're not changing speed, so that means their temperature remains constant. So these flat spots on this graph, those show me phase changes. Okay? So horizontal equals phase change. Now, if I just do a little bit of interpretation from here, I can figure out what those phase changes are. The temperature is increasing as time goes on. That means we're pouring energy into this. So if I'm adding energy, that would make this an endothermic change and this an endothermic change. And so the endothermic change that happens at the lower temperature is melting. And at a higher temperature, it's vaporizing. Now, this actually would be exactly boiling. And boiling is a type of vaporization, so is evaporation. And evaporation can occur at any temperature, but boiling only occurs at the boiling point. And if something's melting, that means it's changing from a solid to a liquid. And if something's boiling, it's changing from a liquid to a gas. So because I can recognize the phase changes, it's easy to understand what's happening in this curve.